This last part, part D, is where people lose a lot of points. Make sure to do this last part correctly and carefully. When we write out the null and the alternative, whatever we're doing when we test two means, we're talking about the mean, the true difference between two means. So let's look at this. Over here in Word, we can go to Insert, Symbol, and we can use the symbol for true mean. Down here we see mu. So let's go ahead and drag and drop mu in. And also, for your PC users, you will see Insert and you'll have symbol over here on the side. So with this in mind, we can write, let's go ahead and go back to layout right here, or home, and we can even do a subscript. Mu males, nope, it's changing it for me and I don't want it to, males minus, let's go ahead and copy paste, females. Let's go back to our subscript right here. Oh, Word, why are you doing that to me? It wants to auto do everything on me. Okay, it's getting testy. There we go. Mu males minus mu females equals 0. We can also describe this as the null. There's our null hypothesis. We can now copy paste this to create the alternative hypothesis. We need to talk about what? And I'm going to let you decide on what the symbol needs to be. There's 6 symbols right in here. One of these symbols is the proper symbol for this test we are performing. Now this will decide what p-value we choose later on. So make sure to pick the proper one. We have a one-tailed less than test, a one-tailed greater than test, and a does not equal two-tailed test. You can put any of these symbols in here depending on what you want. Don't think about which one I'm clicking on. Could be any one of these 6, but it's probably not a certain 3. So make sure to read the question carefully. Does it give any indication of greater or less than, or does it just want to see if they're different? With that in mind, let's actually create some jump output for this question. So we're back here at our random subset of 70. I have some points selected, so let's go and remove the row selection. I'm going to analyze, which I went to in the last problem too, fit y by x. I'm going to see if gender can maybe tell us someone's exam 1 score. So I am using gender to predict exam 1 score. This is not the one you'll be doing. I want to reiterate, this is not yours. We go up here and we hit t-test. So let's look at this. We have a difference between males and females. Males minus females equals 2.3786. That means that males had a higher exam 1 score. And we know this because the males had to have been greater. Well, males are obviously smarter, right? Not exactly. Because we have over here p-values. If you notice, this red line right here is where we fell on this t curve. Look at that, t ratio. With this in mind, we didn't fall far enough away for any of the p-values. Let's look at this. For the bottom one, we have males scored lower than females. No. For this alternative hypothesis, we have no evidence. Males scored higher than females. For this one, we don't have enough evidence. We want this to be below 0.05. Actually, it even tells you, just hover over it, is not significant. Well, thank you, John. I was getting to that. And for this last one up here, males and females have different scores on exam 1s, or don't have equal scores. It's not significant either. None of these are significant. They're not below 0.05. We expected the difference to be 0. That's where we expected to land. We didn't fall far enough away for an alternative hypothesis. So we're going to have to retain the null with this one. Look at your p-values and make sure you select the right one that goes with your alternative hypothesis. Not equals to, greater than, less than. There we go.